Ever wonder how a simple script can play a game, browse the web, or even fly a drone? It's not magic, I promise you. It's all about logic. And today, we're going to dive into Python's control flow. This is the toolkit that turns a dumb list of commands into a program that can actually think. So let's start with that big question. How does a program think? I want you to imagine you have a literal robot assistant. Left to its own devices, it does, well, nothing. You have to give it incredibly precise instructions for every single possible situation. And that's exactly what control flow is all about. It's how we write those instructions, teaching our robot how to make decisions and repeat tasks all by itself. Okay, so here's our game plan for building our robot's brain. First, we'll get the basics down, what control flow even is. Then we'll teach it how to make some smart decisions. After that, we'll make it super efficient with loops, fine-tune its behavior with some advanced commands, and then finally, we'll look at the complete toolkit you'll have ready to go. You know, without control flow, a program is basically just a glorified to-do list. It runs line 1, then line 2, then line 3, and boom, it's done. It's predictable, sure, but it's not smart. Control flow is what lets us shatter that rigid top-to-bottom order. It lets us create different paths and loops that can actually respond to what's happening in the real world. All right, first things first, we need to teach our robot how to choose. And for that, we have our first set of tools, conditionals. These are the absolute fundamental commands that let our little robot assistant look at a situation, evaluate it, and then choose the right path forward. This is really the foundation of all decision-making in code. And the most fundamental command, the absolute bedrock of decision-making, is the if statement. It's really just a simple yes or no question. We tell our robot, if this one thing is true, then I want you to perform an action. And if it's not true, the robot just skips it and moves on. Simple as that. And this slide, it just perfectly illustrates the concept. We tell our robot, if the traffic light is green, go ahead and cross the street. And look at the Python code. It's pretty much a direct translation. The condition is checking if the traffic light equals green, and the action is to run the cross street function. See? It's a clear, logical rule that becomes code. Okay, but what if the light isn't green? With just an if statement, our poor robot would just be stuck there forever. And that's where if-else saves the day. It gives the robot a plan B. If the light is green, cross. Else, wait. Suddenly, our robot is way more robust. It's prepared for more than one outcome. But what about when there are more than two options? You know, like a traffic light could be green, yellow, or red. That's where the if, elif, else ladder comes into play. Think of it as a priority list. The code checks the if condition first. If that's a no-go, it moves on to the first elif, which is just short for else if. If that's also false, it checks the next one, and so on. And if none of them are true, it falls back to the final else block as a default. And the key thing to remember here is that only one of these blocks is ever going to run. Okay, our robot can make decisions. That's awesome. But now we got to make it efficient. I mean, imagine you need it to polish 100 plates. You're not going to write the command polish plate 100 times, right? Of course not. That's where loops come in. They're the tool we use to tell our robot to repeat an action, and they save us a ton of work. First up, we've got the for loop. This one is perfect for when you have a specific, known number of items to process. It's like handing our robot a checklist and saying, go through every single item on this list and do this one thing. Or imagine a conveyor belt with a box of parts. The robot just takes each one, does its job, and stops when the belt is empty. Then we have the while loop, which is a bit different. This is for those times when we don't know exactly how many repetitions we'll need. So instead of a checklist, we give our robot a goal. We tell it, keep doing this action while this condition is still true. Think about it like, keep stirring this mixture while it's still lumpy. The robot just keeps on stirring until that goal is met. So how do you choose? Here's the key rule of thumb. You use a for loop when you're working with a collection of items, a list of files, names on a checklist, you name it. And you use a while loop when you're waiting for a condition to change, like waiting for a game to load or a download to finish. It really comes down to collections versus conditions. All right, let's get into the pro moves. Sometimes just running a loop from start to finish isn't quite enough. We need to be able to tell our robot how to handle special cases or exceptions inside the loop. And that's where control statements like break and continue come in. They let us fine-tune the loop's behavior right in the middle of its run. So first up, break. I want you to think of this as the big red emergency stop button. If our robot is chugging along, processing a list of items, and it suddenly finds a critical error, the break command tells it to just stop everything. It exits the loop immediately and moves on to whatever's next in the program. Now, continue is different. It's not an emergency stop. It's more like a skip this one button. It doesn't stop the whole process. It just tells the robot, hey, you can't process this specific item for whatever reason, so just stop what you're doing, drop it, and immediately jump to the next item in the list. The loop itself just keeps on going. Okay, this next part leads to a really cool, kind of unique feature in Python. What if you want your robot to do something special, but only if it completed its entire checklist without any emergencies? You know, without ever having to hit that break button. And Python's solution is just brilliant. You can add an else clause right onto a loop. Look at this. On the left, the loop hits a break, so the else block is totally ignored. But on the right, the loop finishes its entire run normally, and then the else block runs. It's the perfect way to have success code that only executes when everything went according to plan. All right, next we have the pass statement. And, well, it's kind of funny because it literally does nothing. So why does it exist? It's a placeholder. Sometimes Python's syntax requires you to put some code in a block, like inside an if statement, but maybe you haven't decided what that code should be yet. You can just put pass there to keep Python happy, and it's like telling your robot, I'll fill this in later, just carry on for now. Okay, let's combine a couple of these ideas into a really common and powerful pattern. If you write while true, you're telling your robot to start a task and just never stop, an infinite loop. Now that sounds kind of dangerous, right? But when you combine it with an if statement and a break command on the inside, you create this awesome loop that runs forever until a very specific condition is met, like a user typing quit. So let's take a step back and look at what we've built. This is your control flow toolkit, and these seemingly simple concepts, making decisions with if and else, repeating tasks with for and while, these are the fundamental building blocks that programmers use to construct every single piece of complex software you've ever used. And here's a little cheat sheet for those more advanced patterns we just talked about. Remember, the loop's else clause is for handling successful runs when no break happens. Pass is your best friend when you need a placeholder for future logic. And that while true with a break inside is your go-to pattern for creating loops that wait for a specific event to happen. Mastering these will seriously level up your code. So by getting a handle on control flow, you're not just writing instructions anymore. You're actually designing behavior. You have the tools to make your programs react, adapt, and work efficiently. You can give your code a brain. So the only question left is, what are you going to build with it?